Hello everyone, greetings. On behalf of New Horizon College of Engineering from Department of Civil Engineering for the Building Planning and Drawing Laboratory 19CIVL49, I welcome you for the session. This session will deals with detailed drawing of water supplies and drainage connections to the buildings. The conventional signs and symbols. So these are some basic signs and symbols that has been used for sanitary installations. It starts from shower head, pedestal lavatory, wall lavatories, corner lavatory basins, plain kitchen sinks, kitchen sink with single drain boards, and the water closets low down, water closets, urinal wall hung, urinal stall, Indian type of water closets, water water closet lower tank, water closets with no tank for flush tank. For arrangement of principles and practicing of water supply arrangements in buildings, it is essential for their correct installation, operation and effective functioning. The definition of the following terms should be known. So the following terms are very important when we want to talk about the water supply installation in any buildings. Residential head and available head. It is a pressure head available at any particular point in the distribution systems. It is a pressure at which water is to be supplied to any residential systems. Plumbing systems. It is the entire system of pipes, fixtures, applicants, etc. for providing water supply and drainage to the buildings. Water main and street main. This is the water supply pipe for public or community use and maintained by local or administrative authorities. Service pipe. Any pipe used for conveying water from water main to any building or premises. It is subjected to water pressure from the water main is called service pipe. Communication pipe, the part of the service pipe extended from water main up to and including the stop clock, which is under construction of authority is called communication pipe. Supply pipe, the pipe which extends from stop cock up to the ball cock or entrance of storage tank if any and subjected to water pressure from water main is called supply pipe and it is under the control of consumer. Distribution pipe. It is a pipe connecting the storage tank of various sanitary fittings, tapes, etc. for the purpose of distribution of water inside the buildings. Water supply fittings. Stop clock. Stop clock is a control valve fixed by authority at the end of communication pipe. It is fixed in the street close to the boundary wall in an assembly position in a suitable chamber. It is control. It controls the supply of building from main water line. Ferrule. Ferrule is a right angle sleeve made up of brass or gunmetal. It is joined to an opening drill in a water main to which it is screwed down with a plug and then connected to the hose neck or communication pipe. This ferrule is usually made in size varying from 10 to 50 millimeter diameters. Goswick. It is a flexible curved pipe of 75 mm in length. It follows a flexible connection between the water main and service pipe to expand, and contrast of service pipes is also due to the small earth movements and vibrations. So next thing is something about the sewage, that is drainage connection to the buildings. The wastewater coming from kitchen, bathrooms and water closets, urinals, etc. has to be properly drained in order to maintain healthy environment. If the wastewater is not drained, it leads to stagging in and around the building. It causes nuisance. The requirement of good drainage system in the buildings. The foul matter should be quickly removed away from the sanitary fixtures. Drain system should be able to prevent the entry of gases, vermin into the sewage into the buildings. Drainage pipes should be strong and durable. The pipes and joints should be airtight to prevent any leakage of wastewater or gases. Network of pipes should be sufficient, accessible for inspection, cleaning and removal obstacles. Level of building, sewer and other point of outlet should be fixed accurately. Pipes should be of non-absorbable materials. Branch drain should be as short as possible. Drain should not pass near or under the trees to avoid damage of pipes by the roots As far as possible, drain should not pass under the buildings. Drain should be provided with proper ventilation to avoid air loss and siphonage. The following pipes are being used in the drainage arrangements of the buildings. Soil pipe, it is notated by SP. Soil pipes are the connections to the water closets through which water, liquid, waste includes human excrete flows. Waste pipe, the pipe carrying liquid waste from kitchens, bathrooms, wash basins, etc., which does not contain human excreta is called water waste pipe. Vent pipe, ventilation pipe is one which enables the foul gases produced in the pipes to escape into the atmosphere. Anti-spionage pipes, anti-spionage pipe prevents the self or induces spionage action. If a spionage takes place, the water seals off a trap, suction and give way for entry of foul gases into the buildings through fittings and causing nuisance. Following points should be considered in planning the layout of drainage connections to various sanitary fittings. Layout should be simple and direct. Design slope should be maintained. Concrete pads should be provided to support the pipe laid on the earth fill. Only sanitary tees and quarter bends are used for change of pipes from horizontal to vertical. Manuals should be provided at all points of intersection of pipes. All soil pipes, waste pipes and ventilation pipes may be conveniently grouped in shafts or ducts for easy inspection or maintenance. All surface pipes should be maintained clear distance of 5 cm from the wall. The waste pipe should be separated from house drains by means of gully trap to prevent the entry of foul gases, vermin, etc. into the buildings. Traps are required for very sanitary fixtures. They should be as close to the fixtures as possible. So this is the general layout of my water supply and drainage connection of my building. You can see this. I have this is a water tank, ground floor, first floor, the water closet span, which is attached to the floor level. Then it has been connected to one vent pipe and the drain pipe. Drain pipe will take the liquid waste, and vent pipe will remove the air that is foul gases to the without mixing it with the water, so that it can prevent the water loss. So this is something called soil pipe, and this is an anti-spionage pipe. It is nothing but a vent pipe where it can able to remove the gases. So yeah, this is a section view of my building showing the house drainage arrangements. A layout of various water supply and sanitary fittings in bath and water closets. A different type of water supply pipes like communication pipes, supply pipes, distribution pipes, consumer pipes, location of ferrule, stop clock and storage tanks are being shown here. You can see this A, B, F, G are the communication pipes. G, H, HH and HJ are the consumer pipes. JL, PQ, RS are the pipes. Then second one is a ferrule, which is taken from the main supply lines. Next thing is fourth one is a stop clock. Number 4 is a stop clock here. Next thing is 6 is a storage water tanks, and the supply pipes B, C, D, E are the supply pipes. P, Q and RS are distribution pipes. One is the municipal water main line. So one is the municipal water main line here, municipal water main line, and 3 is the municipal limit what we are having. So the location of this is the municipal limit, and 5 is the first storage tank. You can see this 5 is the first storage tanks. So these are the some different water locations, the different components of a water supply sanitation system. So this is again general layout of water supply arrangement for single story building. So the water main is there. In that stop clock has been connected. Then wash basin, location of my wash basins, and service pipe will be provided. SP service pipe. Again the sink is being provided in the kitchen. Communication pipe. You can see that this is a communication pipe. Shower in the bathroom arrangements. Shower. Ferrule where there has been attached. This is a ferrule for main water line. The communication pipe is being connected by means of ferrule, and tape where we can able to regulate the flow of waters. And these are the some simple layout of my water supply arrangement for the residential building. Again, this in case of for multi-story residential building, So see, if the height increases, the amount of people, that is a vertical increment, increases the amount of people using the systems. So this system increases the amount of capacity of water to be stored in the water tanks. So for this, the water tanks of different level is being maintained, and so you can see this. I have CH1, that is overhead tank 1, overhead 1, overhead tank 1, 2 and 3 are different levels for the different zones. The zones are being divided depending upon the height of my buildings. From there I have a water main line. From water main line I go to for service pipes. From service pipe it goes to riser pipes. Riser pipes, it has been pumping up to the dropping in the particular zones. R1, R2, R3, etc. R1, R2, R3, etc. D1, D2, D3 are the distribution pipes that has been coming from the top level. D1, D2, D3, etc. EM is a water meter that has been fixed to measure the amount of water that has been filled for each levels. Next thing is P1, P2, P3 are the pumps, which is meant for suction from the sump, and D1, DH1, DH2, DH3 are the overhead water tanks that has been provided. This is the general layout of water supply arrangement in case of multi-story buildings. Next thing, something about sanitary fittings. These are the reciprocators devices applicable required for efficient collection and removal of wastewater from the buildings. Sanitary fittings used in the drainage system of buildings include traps, water closets, flushing systems, urinal inspection chambers, wash basins, sinks and bathtubs, etc. This is then again the simple layout of my single-story residential building for the drainage systems. So it includes inspection chamber or the outsides, then then wash basins, WS, it has been fitted insides, water closets, soil pipes. So it will connect both human waste as well as the kitchen waste, rainwater pipes, compound wall locations. So this is a compound wall. Then oblique junctions. This is the OG oblique junction. That is the junction in which the drainage system is to be connected to the public sewer, where PS is a public sewer. Gully traps. So we will discuss about gully traps to collect the surface runoff. We have a gully traps, vent pipes. The location of vent pipe is here. Sink, waste pipes, and water coolers. So this was the simple layout of my single-story drainage system. So this is a cross section of my simple story residential buildings for multi-story levels for the water supply systems. You can see this different parts: water supply from this main straight line, water sump, risers. The notations are being given in the vertical axis. So please refer to these numbers with respect to numbers that is being given here. So for it includes distribution pipes, lower level of flushing clusters, Indian type, trap with water seals, soil pipes, inspection chambers, flow traps, pump, overhead trams, high level flushings, downtake flushings, European tanks, anti-spockage vent pipes, cowls, waste pipes and gully traps. So these are the different locations, different parts of my cross section of my multi-story buildings. These are some notations that we normally represented whenever we are preparing this kind of water supply and sewage systems. It includes soil or combined drains. This kind of dash lines has been followed, and if it's of a surface water lines, a dotted chain line has been followed. Pipes at high levels or on the roof level, a long chain line has been followed, something like this. Pipes at the floor or skirting level, a full line has been followed. Pipes under the floors and intercepting dotted lines can be followed. Then the diameter of pipe diameter of pipe should be mentioned. That is, unless specified stated, diameter of pipe. That is, diameter of pipe should also be mentioned by means of O cross symbols. Circle by that's a size symbol can be used to mention the diameter of pipes. This all notations are being explored according to IS 962. IS 962 will talk about the different type of lines for pipes and drains. So these are some common type of abbreviations that is being used here. Rainwater pipes, then flow taps. I hope you can able to understand the abbreviations with respect to the terms that is being used for water supply and sanitary diagrams. So for domestic purposes, the following points are to be demonstrated when we are preparing for water supply layout for domestic buildings. This is as per IS 2065. Every communication pipe should have stop clocks. To control the intercept of water supply, each separate occupant of a building supplied common service pipe on a stop tap shall be fixed. Consumer pipe is the portion of service pipe used for supply of water which is not the property of an authority. Communication pipe is that portion of pipe which starts at the water main and terminates at the stop clock. This portion is laid by the municipal authorities. Connection up to 50 mm diameter can be made by using screw ferrules. So it will be shown in the next slide how does the ferrule looks like, and it can be provided the size of a it depends upon the size of a pipe which we are going for connections. Air pipe can be provided at the end to release the air at the time of filling of empty pipes, also to guard the water hammers. And when it is necessary for pipes to pass through the water or flow, yes, sleeves shall be provided therein for accepting of pipes and to allow freedom of expansion and contractions. Outlet pipes from storage tanks shall be fixed 50 to 75 mm above the bottom of the tanks. The washout of or drain pipe shall be made flush out at the bottom of a tank as its lower points. Storage capacities for overhead tanks, it is desirable to have minimum storage of half a day's supply in case water is interrupted and hour of supply are irregulars. So these are the points to be accounted when we are going for water supply layout for the domestic buildings. So this cross section, this will talk about the sketch for the layout of buildings for the street for water supply systems for the residential buildings. So this is same thing is being repeated just for understanding in a different views. So this is a supply of neck. There is something called as an ghost neck in type of plane where we can able to increase or expand it and we can able to cross this. And this is a ferrule, the main water line. Drill has been done, ferrule has been connected, it is being connected to the pipe, something like this. So this is the brick masonry chamber for stop clocks. So that can be connected to the tops, which can be able to regulate the move of water flows inside and outside the arrangements. Water supply sanitations. There are two ways of providing a system. One is something called two pipe systems, which means that independent discharge of soil waste and the air vent will be done. So we have one ventilation pipe and one soil vent will be provided separately. So you can see this. This is a ventilation pipe what we are providing. This is a soil pipe. Soil pipe will take the waste as well as that is waste from the water closets as well as the kitchen basins, then to the main sewage lines. To avoid the water, there is air locks or water hammers. We can able to provide ventilation pipes separately from the soil pipes. This is something called 2.2 pipe systems. And one pipe systems, one single pipe can be provided, so that can be connected in parallel, so that it will be acting as a one pipe system itself, so where the soil pipe will be extended in the vertical axis to remove the air blocks, so the water hammer can be avoided. This kind of system is something called one pipe systems. This is what has been shown here in the figure. So again, these are some different arrangement for single stock systems. So that has been normally adopted in the most multi-story buildings to reduce the amount of pipes to economical aspect as well as space aspects. So these are the collection of my residues from where waste wash basins or water closets, and the same pipe is been vertically projected. It has been connected at the top where we can able to allow the free movement of air molecules. So this is the example of my sewage system or water supply layouts. As per according to the IS 191742, the pipe shall be laid in the straight line as far as possible with the uniform gradients. No bend and junction whatever shall be permitted in the sewage except a manholes or inspection chambers. So if there's a bend or if there's a change in direction, then we can provide some kind of manholes or some kind of inspection chambers. When it is not possible to avoid in change in direction of drains, access shall be provided through manholes or inspection chambers. All junctions should be oblique and contain angles shall not be more than 60 degrees. The distance between the inspection chamber and the gully chamber shall not exceed 6 meters. The pipe shall be laid within sockets and leading upwards. So again, this is a water supply sanitation systems which talks about the arrangements, the water supply and sanitation connections for residential building. Starting from the basis, I have inspection chambers IC at regular intervals throughout the pipeline. This is the floor plan. This is where the entire sewage is being connected. But even if I have some sewage outlet, it is being carried out to one single stretch. Then it is being carried to the main sewage line. IC is the inspection chamber, IT is the inspection trap that can be provided, GT gully traps, rainwater pipelines, yard gullies, and pipe vertical down, then entered lower the lintels. So these are some different arrangements: rainwater line, gully traps, and YG is nothing but yard gullies. And the dotted line shows the slope, arrow mark shows the slope where in which the water is flowing. Then it will be connecting like this. Then it will be connected to the main sewage lines. So continuous line shows the sewage line. This dotted lines, there's a higher dots will show the water supply lines, and with the higher, there's again the continuous stretch shows the location of water line above the ground levels. This is again arrangement for combined, that is, if I go for combined bath and water closets, the height of the fixtures what we have to fit in the case of water in the restrooms, that is the water closets has been explained with respect to vertical heights. Again, this is the longitudinal section. This is a cross section as well. That is, I can say this is the entire water system in case of vertical axis. So you can see this, the shower height. SC is nothing but stop clock arrangements, pip clocks, water line from the cold waters. So this is a geyser. Dotted line shows the line for the hot waters. Then this is the continuous line shows the water line for the cold hot waters. So up to this we have seen the different arrangements. Based on this details, just imagine you can consider any residential building plan. In this we may be having water accessibility and water outlets in the kitchen and water closets areas. So in water kitchen we may be have need of water taps near the sink areas, and in water closet areas we may have an inlet and outlets. Depending upon this and depending upon the different fixtures whatever we discuss as of now, you can able to prepare the water supply and sanitary arrangements for the residential building. I hope you can understand the tutorial and best wishes for the further experiments.